Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Well, it is time for yet another episode of the Distributed Data Show, and I love it when we have return guests on the show. So we are welcoming back today Dr. Denise Gosnell.
Hello, thanks for having me back.
Yes, you did such a great job the first time that we knew we needed to have more, and you have brought a friend with you today, is that right? Can
I have.
You introduce your friend?
This is Jonathan Lacefield, but I will let you introduce yourself so I don't mess that up.
Hey, Jeff. So as Denise said, my name is Jonathan Lacefield. I'm the Director of Customer Experience and Graph Products here at DataStax.
Awesome. And so, yes, we definitely have more to talk about in this expansive world of graph technology that we're very interested in right now. There's a lot to explore. Today, we want to drill in on one use case in particular that's really common for graph databases, because not all of them are great. We talked about that last time with Denise, where not every problem is a graph problem, but there are some that are. So we want to talk about entity resolution today. And what is that? When you guys said you wanted to talk about entity resolution, I had to look it up. So where did this term come from?
Sure. Denise can probably give you a very technical and specific answer. I can give you my view on this. And entity resolution is a concept that's actually been around for a little while in the technology world, particularly in the master domain space or ID space as well. And it's really essentially trying to understand if two things are truly the same thing. And that's what it comes down to. And it's really impactful and meaningful for graph solutions, because as you're modeling a graph, you want to connect different events, different people to a single person. And when you have different streams of information coming from different source systems, knowing that one person is, knowing that different source systems are seeing a person maybe differently, and being able to resolve that to an individual person, that one singular person, allows you to build an accurate graph that you can act on and provides a lot of value for your business. I don't know, Denise, anything to add there?
No, that's a really great way to look at the problem and to dive just a little bit deeper. I like to think of this coming from the data science background, or with the data science background. I like to think about entity resolution as the process of taking a really large set of data and inferring through confidence scores or other types of statistical methods whether or not 2 points within that data set are the same. And so problems within entity resolution start to talk about different ways you can go about binning your data intelligently, so that if you have n pieces of data, you're not doing n-squared algorithms, or different ways that you can look at comparing properties. If we're going to talk about exact matching, fuzzy matching, those two pieces not being in more of the graph modeling spaces. Or when you want to look at using graph relationships to do entity resolution, you can look at how two different pieces of data are connected within your overall graph system, and seeing if those relationships are enough to correlate that they are the same person. And there's a lot of really interesting applications of how different companies are solving this problem, both with and without graphs. So it's a really fun problem. My main area of research from when I was doing my PhD, and also some of the work I've been doing out there in industry. So it's a fun problem to work on.
Awesome. So I'm sure you're going to tell us some of the details of that. But just to kind of start out with, why do I need this? Or what are the benefits that I get if I have an entity resolution solution in place? What does that allow me to do?
Yeah, and I think Lacey started to touch on some of the overarching benefits, but at the core, when I think about needing and wanting to model the relationships that are inherent amongst graph data, in order to create a graph model, you need to be able to infer and deduce the one version or the master identity of, say, a person that is within your data set. So as far as the benefit goes, what that gives you, what really is the foundation for starting a more customer-oriented model, or just really any graph model that can model relationships between people, the underlying foundation amongst that is being able to solve entity resolution. You've got different data feeds about your customers coming in from all different sources within your company, and it's a really hard technical problem to be able to infer who's the same amongst all these different data feeds, and it's at the core of being able to create a graph model.
Wow. And it sounds, not to harp too much on this as only talking about users or people, like it seems like it could be part of the solution to solving some PII issues that we may have in different systems, but then also in itself is maybe an area that we need to exercise some care in protecting identity of people, right?
Yeah, it's interesting, particularly over in Europe right now with GDPR. Entity resolution is becoming very important because there's a regulation that says that a person has the right to remove all of their data. Well, if you don't know it's their data because your systems can't figure that out, then you're out of compliance, and that's not an acceptable response. So it goes right to your point there. It's a very very challenging thing to figure out.
Okay, so we've kind of outlined what the problem is. What is the DataStax answer to this? Like, do we have a solution for this?
Yeah, sure. So tell you what, let me take this from a high level. I'm a product manager guy, and then Denise, who gets to go out and work with our customers and actually implement this, and leveraging all of her expertise there, can drill into some of the details. So we really recently wrote a blog on this specific point, Jeff. It's actually out on DataStax Academy. And our view of DataStax, though I am the graph PM, Denise mentioned she's here representing the full platform. We believe that entity resolution is really a platform solution. And when it comes down to it, there's 3 different ways people are using the solution to solve entity resolution. The first is through pure search kind of matching, and that can leverage fuzzy searching or exact searching and everything in between. But it's essentially, is this person who we think they are based on pure search and match. The second is to infer data once you've loaded into the graph. One of the neat things about DSE is that we're an integrated platform, so graph and analytics are truly integrated. Once your data is inside of graph and these separate vertices, separate nodes, you can use DSE analytics to do some of that inference to understand if 2 different vertices truly are the same, and if they are, then you can do some linking there or some next steps. So the first being pure, search graph or pure search kind of way to match. The second being an infer based on graph and analytics. And then the third, Denise was kind of talking around earlier, and that's really leveraging more of DSE analytics. And I think this is a lot of her background, but it's to do infer just on raw data sets. And then once you find things that are the same, coming up with a master ID, loading that into graph or into the DSE core itself, and then acting on the solution. So that's how we see it, from my kind of higher overarching level, really those 3 different ways.
Yeah, and that's actually a really interesting thing to kind of note, knowing that I'm transitioning from more of a data science role who is solving these problems to getting to be a part of the platform, like the data management platform. It's really fascinating to me to look at the space of entity resolution and the types of techniques that you would use to solve this problem, and just look at the tools that are available, and why that it's really important to understand to use the right tool to solve the right aspect of the problem. And so it was an interesting lead-in to look at how some problems are graph specific and some problems are not, because within the entity resolution space of the different ways you need to do the fuzzy searching or matching, like Lacey just mentioned, or even relationship inference, you want to make sure that you have the platform that's going to allow you to do, or enable you for fuzzy search, enable you to do more deep analytics, or even start to use different entity relationships to determine if you've got bad apples or illicit actors or other types of specific communities within your data. And as far as the current solution state, every entity resolution problem and every aspect that I've been involved with has to find a unique way to combine those tools to solve the problem in your domain. So you can't really go after an entity resolution problem without really fully understanding the type of data that you have, distributions of strong identifiers or lack of strong identifiers within your different data sets, and being able to see which keys and values or which types of relationships can create that match to be able to say data point A here is the same as data point B from this data set. And so it's very vital to make sure that you have a platform that gives you the ability to solve every minute problem that transcends, or maybe not transcends, maybe is the underpinnings of all of the details that go into solving this as a large solution.
Good, and I like that you aren't not trying to coerce every problem into the same cookie cutter kind of solution there. So that makes a lot of sense. But all the same, are there a set of kind of common patterns that you see recurring again and again in the solutions for these?
Yeah, Jeff, that's a really great problem, and there's a lot of different sub problems here, but there's a few that I feel like are much more frequently observed when you're looking at different approaches to solving that. And that comes down to more of the binning techniques, looking at different ways to do streaming, and then different large bulk processes for doing comparisons. So for each of those, the sub problems you're gonna find when you're wanting to do entity resolution. The first one I mentioned was binning. And let's say, for example, that you expect to have 100 million different data payloads coming into your system over some length of time. And your goal is to be able to, with some type of confidence, be able to determine amongst these 100 million things which represent the same identity. And I would never recommend that you would build out a system that would be reliant on doing some type of n squared or even worse algorithm across 100 million potential data points, and even larger for some of the systems we're working with. And that's where you can start to talk about different binning strategies where, but you know that you're only going to be close to maybe 4 or 5 or up to 20, 25, 100 other data points. So let's make sure we understand our data, we understand the types of identifiers that are important, and we're siphoning off common looking data points into a certain data model in this area. And maybe you end up with 1,000, 10,000 data points over here. Instead of looking at the whole 100 million and doing some type of n squared algorithm, once you've intelligently binned your data, you can take a smaller approach to do some type of comparisons within that smaller subset. So whenever you're starting to look at entity resolution, that's one of the first problems you need to make sure you understand is how to bin your data intelligently.
So does binning, that sort of sounds to me when you say that vaguely like a partition key. Is there any relationship there?
There can be, and that even kind of starts to get into the world of materialized views. And so a rule of thumb, or a way, again, I would say at its core, an approach to any of these techniques requires a fundamental understanding of your data and understanding the keys and values, their unique distributions, the types of strong identifiers we're working with, any type of additional domain knowledge that can help assist in the creation of a match. But with that said, let's say in your domain, it's perfectly acceptable to have a match of 3 out of 5, for example. So you've got some type of like an email, phone number, social security numbers, those types of things that are strongly connected to a human's identity in the digital age. What you can look at doing, kind of using Cassandra tables and materialized views, potentially, don't know, it depends on your application. But you can look at creating materialized views and duplicating your data across these different ways in partition keys to create a large bin for doing a subset comparison when you have exact match on a specific ID. But that already gets you down a specific hole and down a specific view of the data that you can match with. And if that's unacceptable for your application, you might want to come up a little bit and not make such a strong assertion on a partition key level like we were just talking about. So it does depend, and it requires a lot of exploration of your data and understanding what you can do and can't do as far as creating matches.
Yeah, probably a couple interesting things to highlight what Denise spoke about, and I'd be interested to hear what our customers are doing. But what I'm seeing is this entity resolution has really two sides from a data flow perspective. There's certainly a batch. There's this, I need to seed whatever the source system is, whatever my known good source records are. Mm-hmm. And then there's this, real time flowing in. Maybe it's, low latency, high volume, high throughput, or maybe it's more, kind of what we would expect to see from a web type of scale application. But the real time need of entity resolution as well. And so Denise, I'd be curious about, how we're solving this today and those two angles.
Yeah, that's actually a really good, really solid way to kind of frame some of the other two main trends and patterns that I was seeing. And I would frame them, I think, using the word streaming or bulk searching and things like that, we can reframe that, kind of what you mentioned from a labeled data set. You can think about how you have your supervised problems, your supervised machine learning component to the entity resolution problem, and then the unsupervised component. And at its core, after you've really gained a solid understanding of the properties amongst your data, I always recommend that you start with some type of gold standard labeled data so that you understand from a supervised perspective how to train your model and how to train and learn which features are relevant to your entity resolution matching problem. And when you turn on the streaming component and you're looking maybe at entities that you haven't seen before, that's when you start to trend more into unsupervised matching. So you already have this population of data stored in your database. Most likely, if it's going to be a master identity model, we're looking at a graph database. And what we can do is, as you're processing a new payload of immutable instance data, just an observance of an identity, you can stream and connect it to an existing master identity, or according to some confidence level you've previously determined, you can say, I'm pretty sure this is a new identity. I'm going to insert it into my database as a new person. And so with each of these feeding each other, once you've had your streaming component build up, it's necessary to go back and examine the types of matches you've created as you had more of your unsupervised streaming matching happening. And that's when you can go back, take it into more of an offline batch and bulk analytical approach so that you can measure and kind of observe the types of false positives that you potentially have connected together from your unsupervised model. And so with those two components, using labeled data to train your supervised algorithm to determine which features are relevant, and then putting that out into production for real-time streaming solutions for more of an unsupervised approach, those two subcomponents, I feel like, Lacey, are good descriptions to understand patterns and other ways that people are solving this problem.
Wow. That's why she's a PhD and I'm the product manager, by the way. So.
Yeah, it's thank you. That was very kind. Mm-hmm.
Okay, well, I love it when we actually get it to dig into some practical use cases and not just always talk about technology in the abstract without reference to a particular problem. So thank you guys for taking on this tour of entity resolution problems, and I hope that we could do more episodes like this in the future. So thanks for joining us today, guys.
Yeah, thanks, Jeff. Thanks, Lacey.
All right, guys. Y'all have a good day.
All right, until next time.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.